A mother hawk screeches as she dives at you. You recall from biology that female hawks screech at 800 Hz, but you hear the screech at 900 Hz. How fast was the object approaching? So this question is representing the Doppler effect, and the Doppler effect is observed when there's a source of waves moving with respect to the observer. There is an apparent downward shift in frequency for observers whom the source is receding, vice versa, an upward shift in frequency for observers toward whom the source is approaching, which is what we see here. The 900 Hz is what we hear, and then the 800 Hz is like the actual frequency of the screech. This equation here is the equation for the Doppler effect for an approaching source, where F plus again represents what we hear and F naught represents the actual frequency of the screech. And V represents the velocity of sound, which is always 343 meters per second in air. And then Vs represents the velocity of the source, which is what we're looking for. So using this equation, we have to isolate Vs. So to do that, I'm going to just do some algebra to get it to the other side of the equation. So first thing I'm going to do is just multiply this whole denominator to get the Vs on this side of the equation and in the numerator. So I'm just going to multiply both sides. These guys are going to cancel out. And then from here, I'm going to distribute the F plus into this guy over here. And then I'm going to subtract the F plus. And then from here, I'm going to multiply by V, divide by F plus, and then multiply it by -1 so that the Vs will be positive. So this is our final equation for Vs. Now from here, all we have to do is plug in the numbers. So we're going to get F naught is 800 Hz, so this will be -800 Hz plus 900 Hz, which is F plus, times the speed of sound in air, which is 343 meters per second, divided by F plus, which is, again, 900 Hz. Now, if we multiply this out, we should get our final answer of 38.1 meters per second. So this is how fast the object was approaching.